My name is Nick Weaver. I work for EMC. I'm a senior V specialist. I'm a blogger. I'm on Twitter. If you follow me on Twitter, raise your hand, just real quick. Okay, that's not good. I do a lot of free tools. If you guys went to Kenny and David Davis's session, one of my tools is in there. I blog on Nikipedia.com. I've been involved with the Solera. Who here has used the Solera VSA, the Uber version from EMC? So the last version of that I've been involved with. Do a lot of weird stuff. At the core, though, networking is one of my favorite things. I've started being a desktop guy, then wanted to be a network guy, then found out about virtualization, and now I kind of come back to network guy again. So I'm going to cover, this session's more about the theory and the approaches and the way to think about networking in a virtualized environment. I'm not going to dive down into click this checkbox and do this setting. My goal in this session is to try to open your mind up and make you look at things differently in your environments and try to inspire you to maybe find a solution where you didn't know if there was one before. If you want questions, I'm going to take a lot of questions at the end, but during the session I'll stop and ask if somebody has a question, and I'll try to be interactive with you guys. That's okay. So with no further ado, let me get started. Oh, can you guys see me okay up here? Kind of? No? Okay, good. One more thing. Who here has seen the rap video? Okay, if you can just form an orderly line and walk out, that'd be great too. So real quick, I want to discuss how networking is changing. So you guys have seen the change with virtualization. We started with these very one-to-one mapping kind of things. We were stuck with very rigid, non-flexible ways of architecting CPU resources. And then VMware comes along and changes our world. And now we were able to drive, with logical abstraction, much closer to efficiency, to scalability, some really cool flexibility. And the reason you're here is because you know that. Well, because of that, and because of those changes, other components of IT infrastructure are being affected as well. And networking is a big part of that. And so this landscape and the way we look at things has completely changed. So like I said, things started back in the mainframe days. You bought this big, massive amount of power, and then you logically carved it up for business units and for processes and batch processes, different things. Raise your hand if you worked on mainframes. Wow, that's more hands than last time. You guys are smart folks. I just want to say that. Then we moved on to client-server. We kind of paired things up, many to one, based on the business unit. They got an application for this, got a fat client that connects in, that kind of stuff. You guys work with that. Then we moved to the whole web world. We get to these thin web applications where the client side gets even thinner, and you have this universal interface to access through. Now we've got this definition of what's called the cloud. And who here's heard about the cloud? Okay, a couple. All right. So the cloud is kind of an abstract in itself. The term is a logical abstract. It doesn't really quite define what it means, and it's different for each person. But the idea of the cloud is a quick consumable. The most important thing to realize about a cloud is every single component of IT infrastructure related to it has to be just as flexible. You can't have compute resources that are highly flexible and logically abstracted, and then have networking resources that aren't. It won't work. I'll explain more about that. So let's go back to abstracted servers. I'm going to illustrate a couple things here. So you had that old days where I had an application in OS, and I stuck it right on this one server. All right? You might do that? Okay, good. You put it on this one server. But what happens if you want to move that application in OS to this server over here? What do you got to do? Reinstall. So you got to put the operating system back on, then you got to put the application back on. If it's stateless, you're probably okay. Make sure the settings are right. If it's not, then you got to go get all that data and get it back over here. So not really cool, right? Kind of painful. So that's where virtualization came in, that it abstracted the application OS from the hardware. You guys know this. What's really cool about this is it gave you the flexibility to move things between, and it broke that abstraction. So then we look at abstracted ports. You had the same physical server, and you got these ports on it, and the port was directly tied to that OS and the application. And then VMware comes around, they virtualize the CPU, but they also virtualize the network, and that a port on a server is no longer bound to one application or one OS, is it? You got a vSwitch in there, you got uplinks, you got multiple port groups, multiple VLANs, you got VM kernels, you got all these components all coming across these ports. You've abstracted that port. And now we're also getting into abstracted fabric. So this is the old school model of your separate data path for network traffic and your separate data path for FC traffic to your storage. As we're going along, the future is going to be where the fabric itself is no longer going to be, the media and the protocol type are not going to be tightly matched to what you want to put on top of it. You guys look at FCOE, in DCB, what we're getting to is an abstracted fabric where I can take this cable and I can use it in any one of these servers, and I can run multiple protocols on top of it, but I don't have to worry what the color of that cable is or which thing it goes up into. I've abstracted that, which gives you that whole scalability and cloud flexibility. So I say all that to illustrate that all these abstractions allow us to do one thing. Instead of being tightly coupled to a piece of storage or a piece of networking or a piece of compute, I break those boundaries. What that allows me to do is use multiple pieces. So I can be on this point of storage or on this point of storage, on this piece of networking, on this compute. And I can treat my environment as a consumable resource much easier. It's very important it has to happen across all the levels. And that's my definition of what a cloud truly is it's a cloud of infrastructure where I've abstracted all the elements out so I can consume, I can carve up, I can prioritize as I need. So I want to talk about the landscape today, what we have today as far as networking specific. If you look at the evolution of switching, so in the old days, which are the old days over here, you had the network guys over here in the pink, and which it wasn't the pink when I chose that, but in the pink, and you got the blue over here as your system administrators. And there's a real cool line of demarcation. Network engineers knew their area, and the system engineers knew their area. And every time you wanted to make a change, what happened? You got the system engineer pick up the phone, call the network guy, and say, hey, I need to get a VLAN. The network guy could do what? You might want to answer that. What happens to the network guy? He goes into a port, right? He says, okay, bam, this port right here is what you need to plug into. The system guy goes and plugs in, everything's good. Right there's the line of control. And then in walks an ESX server. And everything's a little off balance now. All of a sudden, the network guys got these switches upstream. The system engineering guys and the VMware administrators are saying, hey, I want a port trunk up into it because I want to control my own VLANs in my port groups. I've got control up in here. And it created kind of some new operational problems the way we look at things. And then you get the DVS switch comes in, which is really cool because now you can actually take these hosts and have a unified control. So at least you get the settings right across all of them, right? Before with the two different V switches, you had to make sure everything's perfect for each one of them. Now you get that unified control. But the real balance was restored when the 1000V came in because it allowed the operationally for the network engineers to have control at the edge of the VMware environment and have control as far as things like remote port spanning, quality of service, and things like that. So I say all that not to say that the 1000V is the way to go, because in reality there's a host of different options and features and choices between all three. What I'm going to do is illustrate what those features are, because what you want to do is you want to choose the best one for your environment, the best one based on your needs. So let's talk segmentation. So you got physical links, have been all old school. I know what this line is. My blue cable is this, my yellow cable is this, and my red cable is this, right? Then we move to VLANs, which was a logical abstraction. You're going to hear me use that word a lot. A logical abstraction of a physical link. And that I can have a single physical cable, but I can run multiple layer 2 segmented subnets and domains on that same piece of cable. Do you know why that got so popular? Scalability, flexibility. If I've got a server that's got to be a member of multiple networks, is it a smart idea to have one NIC port for every network it's got to be on? Now think about that in virtual terms. Why do we use VLANs on ESX servers? Scalability reasons. If I can have a single trunk up there that I can logically abstract those networks on top of it, that gives me the ability to have a dense ESX host. And don't be mistaken, the whole point of virtualization comes down to one major thing first and always, efficiency. So run more on less, but the problem is you have to have that abstraction to accomplish it. So with VLANs, there's a couple issues, though. One of those is security. You see a lot with PCI compliance issues and things. You've got to protect the fact of VLAN hopping, things like that. I'm not going to go deep into that in this session, but the same things you look at in the physical world with protecting VLANs apply directly into the ESX world. And you have the same kind of controls in place. Another thing I wanted to talk about was private VLAN. So if you're thinking about security, and you're thinking about how to segment but also protect things in between, an interesting thing about private VLANs is it allows you to segment what? Anybody?
Single VLAN.
A single VLAN. So if I take a single VLAN, who answered that, by the way? Thank you. So if I take a single VLAN, and I have two VMs and I segment them from each other, I've got another logical abstraction, haven't I? I have a way of carving up a VLAN in itself. That's kind of the cool thing about private VLANs. So what is the first level of control you have on an ESX server is a VLAN. Now you can go and plug up physical ports and dedicate uplinks to physical. You can do that. You're not going to get a lot of stuff on that ESX host. So in reality, the VLAN is where you start. Well, the private VLAN is very cool in that you have another logical abstraction to go in and carve up sections of a VLAN for control. I put this illustration up here because in this illustration I've got two applications sitting inside the same VLAN, which need to go outbound or inbound from two different firewalls. And I want to DMZ those guys from each other. Well, with a private VLAN, even though I live in the same logical VLAN space, I can keep these things separate from each other and downstream to the firewalls. That make sense? No? Nod some heads? Give me some nods. Come on, little nods. Awesome, awesome. So let's talk about segmentation with DCB, 10G, and FCOE. So this is where we've all been used to. We got two physical lines. We've got our fiber channel protocol, and we've got our Ethernet. So I've got two links that go into my servers. And we've gone through all the cool stuff with VLANing now, so we can have multiple VLANs on that. We've gotten real dense. But how many cables do I always have to my servers? At least. See, best practices, guys. That was good. That was good. At least two, but these guys are smart. They must get paid for that. So this is really cool, but I've got an issue in that this doesn't scale very well in reality. Does this look like what you see is the virtual logical abstraction? I've got two different types of two physical medias here. So that's where DCB comes in with FCOE, and that I can take and create a modified Ethernet link. It's got new features, new adaptations to the protocol. It still runs VLANs the same way on top of the medium. But now I can take my FCOE and FIP frames and run them on top of the exact same medium. So what have I done here? I've taken the old school single links to each piece, and I've abstracted it onto a single link. So the same way that I abstract my ESX servers and put my applications on top, the same way I abstract those ports, I've now done that to the fabric. And that I can run a single link in and have multiple things running on top. What does that do? It gives you the same flexibility, the same scalability. And I'm going to illustrate that in just a second. Any questions on this? Feel free. No? Okay. So let's go back to this, the evolution of the fabric. The problem with this is every time you've got to add a node or you've got to control a single piece, you've got to do it by the type. So if I have new servers come in and I have to add in fabric pieces to my SAN layer, and I'm running low on ports, I've got to buy another SAN switch and expand that way. And I have different paths and channels. I mean, how many of you guys go into your data centers, if you have a data center, or your customers' data centers, you pull up the tiles, you look overhead, you just got these massive links running here and there. Tree off this way and tree off this way. Well, what if, from the server layer up to the switch, you didn't have to do it? And if you look at things like the UCS or CNAs inside of commodity servers, we now have FCOE, where the 10G network and the fiber network run directly inside up to a central FCF. So a good example of this is, in this case, these will be 60, these little blue guys. See if this works. You guys see that? These little blue guys right here. Those are what we call dual stack switches. Now, dual stack switch has the ability to intelligently understand both types of traffic. Let me illustrate that. Sir, would you mind standing up for me? I promise no dancing or anything. No rap video. Jason, would you stand up for me? Just stand right here. All right, John. You're in the middle. So in my normal data center, what's your name, sir? Rusty, thank you. So Rusty over here is my Ethernet switch. And I'm a server. And Jason over here, Jason's a great guy, by the way. Jason over here, he's my fiber channel switch. So as a server, I've got unique connections to these two guys. But I have to have that traffic separate. And I go, here you go, man. Here's my Ethernet frames. All day long, just handing my Ethernet frames. That's all he knows how to handle. And likewise, I've given Jason over here my fiber channel frames. And then they forward them up into the network. All these dual stack switches these FCFs are doing is my buddy John here, he's a super switch. And he understands what this guy talks, and he understands what this guy talks about. So I can hand him either he'll sort it into the correct piles, and he'll hand that off to Jason, or he'll hand that off to Rusty, and down the line. It's as simple as that. There's just a switch that has the ability to intelligently determine each set of packets, handle them differently, and hand them down the line. Thank you very much. Appreciate it. I won't thank these guys. I know them. So the future of this is, I'm just teasing. The future of this is this right here. Eventually we will have, and if you look at Fabric Path with Cisco, and some of the things Cisco's doing and other vendors. The future is the ability to have a single fabric, a single physical media that's going to allow us to run multiple protocols. If you think about it right now, we're talking Ethernet and fiber channel, or in FIP as well. The way this is going to expand is immense. The important thing to realize is right now this isn't happening because if you look at an Ethernet standard in Ethernet, let's see how cool my audience is. Who knows what the big issue with Ethernet and fiber channel is? Lossless. Yeah, very good. Who said that? Winner, right there. You get a free one of these when I'm done. So, Ethernet is lossy. It does not guarantee that if I hand Mr. Rusty a packet, he is not going to guarantee me that he's going to hand it to the next person. There's a higher level protocol like TCP which can guarantee for me, and then it'll babysit and retransmit and let me know that it didn't get where it was supposed to go. Fiber channel doesn't work that way. Fiber channel, my friend Jason over here will guarantee me. He can. There's different modes, but he can guarantee me that he'll make sure that gets there at that layer. So that's why it's very important. If I mix in this guy over here, he's good with this guy, but he's got to make sure that he brings that extra congestion notification, command queuing, and the ability to guarantee that if I hand him a fiber channel frame on an Ethernet backbone, he'll make sure it gets there. If you look at this right here, the reason that we're not getting the multi-hop as of yet is because as you get tiers and tiers and tiers, that's where you start to get the risk of losing packets down the line. So as DCB gets more ratified and extended, we get command queuing and some cool things to actually get that control at layer 2. You're going to see the network turn into this. It's coming. Any questions on this? Yeah? Oh, there's nothing wrong with iSCSI. Absolutely. In fact, NFS, iSCSI, FCOE, FC, all great protocols. Each one has their use cases. I would say it depends on the environment. So iSCSI works at a much higher layer. So if you have, let's say in this case where you have a single unified fabric, your 10 GE links could still run iSCSI in them. It would be unaffected. The important thing to realize is the standard is about including the fiber channel, less than changing the regular TCP stack above. So all your iSCSI runs perfectly the same way. It's just for shops that prefer fiber channel for specific reasons, scalability reasons. The idea is to maintain fiber channel, but let's get a single medium. Let's abstract it. Let's get where we can have less cables. So, and I go back to the illustration about the big runs, right, underneath the floor and in the racks above. Getting away from that. If you're going to a cloud environment, we're going to have dense servers, and you're going to expand out. You're going to have 10 servers that run thousands instead of 1,000 servers on the floor. How are you going to put all those thousands of cables into that same footprint? Well, you're not. That's why this is extremely important for the expanding data center. And let me illustrate that. So let's take a for instance here. So let's say we have 50 physical servers, and I've got one gig Ethernet to each one of them, and on 20 of the servers I'm SAN connected. So I've got 2 4 gig FC links on each one. Total bandwidth you can see there, but the important thing is the cable count at 90. And trust me, I was very detail oriented in making my PowerPoint slide like this. That's exact count. Surprising, right? Yeah, he knows me. What's really important about this is the physical server. So this is my physical data center. I'm old school right now. This is 5 years ago. And then VMware comes out, and I go, holy cow, this is cool. So I'm going to virtualize these physical servers. I was running 20% utilized all of them. So I'm going to get them all dense. I'm going to get down to 5 ESX servers. So I got everything all virtualized on there. Well, immediately, what do? I cut down on my links. So I still have to have quite a lot of bandwidth because I have the same load. So I've gone to 10 1G for each one of those servers. And because they're all SAN attached, I'm now at 2 4G for each one. So my bandwidth has come down. Now, did I lose anything by the bandwidth coming down? Probably not. I probably wasn't utilizing all that bandwidth. I was connecting all those for what reason? Because I had to, right? So in this case, I'm down to 60 cable count. So I'm completely virtualized. So if I take this right here and I go to a unified fabric, what does it look like? It looks like that. I get down to 2 10G links running FCOE for each one of those 5 servers. My bandwidth actually goes up a bit. Now, with Fiber Channel, the fiber is actually guaranteed, and my cable count goes to 10. Now, take this illustration and think about that in terms of 1,000 servers. Service providers, very dense environments. Those long runs above and below can be reduced by quite a lot. This is going to be extremely necessary as clouds build out. Any questions on this? Yes, sir.
Technically, it's entirely
has required some accredited, separator between these pieces. So in this new technical architecture, I think to gain adoption, standards bodies like common criteria, the vendor needs to assert these up and say, here, this is not just trust us, this is a third party independent recognized internationally, that this is a secure configuration, because you could have a human error causing some contamination, allowing infections. Right now you have your DMC traffic and your admin high.
Right. So you're completely right. And a comment as far as the common accreditation, if you look at the VBlock with VC Coalition, that's a route we're pursuing as far as seeking the third-party accreditation for it. But he's completely right. So when I take 10 physical servers, right, and I put them on one ESX host, have I incurred more risk? Yeah, absolutely. Absolutely. So if I take 10 physical links and I put it on one link, have I incurred more risk? So did that stop people from virtualizing? Did it slow it down? Did it cause some headaches? Did your security guy give you heck in a conference room? Raise your hand. That's me. Yeah. So there's going to be, it's absolutely a great point, there's going to be hurdles to jump. There's going to be a whole new thought process around this. And that's part of the reason I'm doing this session is you got to really think about these things because it's going to have to happen. So I'm going to talk a bit about OTV. I'm not going to dive in deep about this, but I want to bring it up. So if you look at a ESX host, for an ESX host and an ESX host side by side, buddy to buddy, to move a VM, they've got to have layer 2 access to each other. All right? So layer 2 is really the medium and the domain for an ESX host. Well, when we're getting to this future with vPlex and technologies like that, which allow you to actually move a VM from physical site to physical site to physical site, or from SAN to SAN at distance, you have to be able to have that connectivity. But in our modern networking, as awesome as it is, we have these layer 2 islands with layer 3 hops in between. You've got to go up to layer 3, traverse something, come back down. So that isn't compatible. So all OTV does is it allows you to extend unique VLANs between unique layer 3 subnets. What that basically means is that the ability to move VMs from site to site to site. Like I said, I'm not going to dive into that one. I don't have time for it. And there's better guys than me here. If you really want to know more about OTV, I really highly recommend you read Brad Hedlund's website. If you're writing notes down, that's Hedlund. He's my hero as far as this kind of technology. This is important to realize, though, because I'm going back to talk about the layer 2 importance. Layer 2 is highly important in ESX environment. So let's say I've done all these steps. I went through all these processes. I went and got my nasty cabled out network, all physical hosts. I've gotten down to these really cool, powerful, virtualized, highly dynamic, unified fabric environment. That's all well and good, but if I don't utilize that environment correctly, it's not really worth it. Think about DRS for a second. So if I take 10 ESX hosts and I throw a bunch of VMs, just shoot it across them, well, DRS will load balance across. Without DRS, how effective is that? Only as effective as the guy that's doing the vMotions, right? So utilization is a very key component to virtualization efficiency and abstraction efficiency. It's one thing to bring the method in to allow you some flexibility and control, but you've got to utilize it correctly. So I'm going to talk a bit about connectivity from an ESX host and options. Right off the bat, one of the first things you can do when you set an upstream connection for a vSwitch is port ID. So it's pretty much explained by the graph there, in that each one of these hosts gets pinned to an uplink based on, so you got that virtual switch in there, right? It doesn't actually exist, you got these unique ports on them. A port on that switch gets pinned to an uplink. Why is that so cool? It's easy. I just flip a button, I'm done. Do I have to have any special switches over here on the right? Anything special? No, it's just bam. But what if those 3 hosts with the red links are 80% utilizing their traffic and the blue ones are 10%? How well utilized am I? Not very well, right? So there's the bad side about this. Very easy to do. Then you have an option for IP hash, which takes a hash of the IP address, source IP, and will balance the links across. So what that allows me to do is have a single host balance better across the links that it uses. Is it done intelligently based on load? No. So it's just more granular is the way you want to think about it. The difference between the one before is I got these 2 links, your A or your B. With this one, the granularity of which traffic is based on IP address. Where's the gotcha for this? That right there. You got to have downstream switches which have the ability to cluster. And if you were like me as a customer 6 months ago and you didn't have those, you were pretty upset. So then we have the new technology, LBT, that's come out with 4.1 on the distributed virtual switch. What this does is you still have a pinning, but if one of those links, like my red one right here, gets saturated, it gets over a certain point of load, the ESX host will go in and it'll distribute those better across the hosts. So the benefit to that is that it's reactive at least, and that if something gets out of sync, it'll put it over. But it's not like it's dynamically, intelligently making decisions. It's just a threshold. If my traffic gets to this point, move over. And the way you sort it, you don't directly control that either. Then you look at the 1000V. So the Nexus 1000V, we talked about it before, is the higher tier of the switch. In this case, the 1000V has an option called MAC pinning. Does anybody recognize does MAC pinning look familiar to a previous slide? The port ID one, right? So once again, it's the same theory. It's simple. The MAC address of the VM is pinned to an uplink. What happens if that uplink goes down? Anybody? It just goes over to the other one, right? Well, I hope so. But yeah, it goes over to the other one. So again, very, very, very simple to implement, but doesn't necessarily give you the best utilization. The 1000V also has something really cool with the port channel. It's the same kind of idea. The difference is you get 17 unique different ways of creating that hash in between. So you can consider things like the TCP port. And the way to think about that is if you've got, let's say you have a database server. We got many, many, many connections come in from a whole host of different enterprise apps, right? If you can set it based on TCP port, then the traffic of that server will load across as many interfaces as you have inside that port channel. It allows you to spread the load across. What's the gotcha to this one still? Clustered switches. So, another option is the VPC-HM, virtual port channel. This one's a lot more complex to set up, no doubt about it. In fact, if you look at Cisco's manuals, they'll tell you, just go with MAC pinning. Unless you got a reason, just kind of do MAC pinning because it's easy. What's cool about this is what I do is I create a virtual port channel, this big one right here. Inside that virtual port channel of links, I create two uplink sets, A and B. Those links can be multiple links. So these little guys in here can be that 17 different modes of port channel trunking. So I can do that TCP port based, but inside that big one I've got two paths. The benefit to this is, what do I not have to have? Clustered switches. But I still get the benefit of having multiple links inside of a set that I can load balance across. This is the most powerful one, but it's also definitely the most difficult to set up. So you want to be able to judge whether you need it or not. So utilization is partly about how to distribute load, and it's also partly about guaranteeing that the VMs that are important get the traffic they need. And so with that illustration, I want to talk about utilization with QoS. And one of the first things that came out, and first things you guys probably know about, is policing traffic with shaping. Basically, I say if I got a pipe coming down on this port group, I can say, goes no faster than this. And with the vSwitch, I can do it in a single direction, and with the DV-switch, I can do it in both directions. Now, by limiting the traffic on a VM, am I guaranteeing any other VM traffic? I'm not. All I'm doing is saying no. I'm not saying yes to any other VM. So if I got 100 VMs and I do this to 99, I can reasonably assume there's something left over for the 100th VM. But there's no guarantee in this mix. You're just trying to keep the bad kid in his desk. You're not guaranteeing the kids are paying attention. Now we have the ability with the new changes in 4.1 to actually police by traffic type, which is pretty cool. So if you know you have like vMotion happy VMware admins and you want to limit, you can do that. Or you have a certain set of virtual machines you want to limit. This still is just the same mechanism applied to a different logical approach to it. It's just limiting. The coolest new feature is the new network I/O control. What this allows you to do is go in and assign shares to each type of traffic. And in those shares, the same way you would do real quick poll. Who uses resource groups and shares in your current environment? So it's this couple. Wow, it's not as much as I thought. So a couple of you guys will know this is the exact same theory in that if there's a contention, so these guys are cruising fine. It's 3 in the morning, no one's logged on. 8 in the morning hits, machines turn on, marketing opens their email up, things start getting contention. Under contention, there's rules set now that you can choose who has priority, who has what share. So in this case right here, in a contention environment, my virtual machine traffic is guaranteed he'll get 50% when a fight happens. That's pretty cool. This is a lot more intelligent, but once again, it only happens under contention. So what I've just talked about is one facet of quality of service. And that's really something I want to illustrate for you. This is policing. It's the ability to tell something not to do something. If you look at the actual stack of quality of service and what's involved, it's much, much larger. That's where the Nexus 1000V comes in. So there's several different modes to quality of service. The first one's classification. A packet comes in, and it looks at it. What is this? You define rules. Is it marked? Does it come from this protocol? What is this packet, right? And you can also mark a packet. So a packet comes in, you classify it, and you say, you know what, this one's an important packet to me. You would do that at the edge, and you can mark it and say, this one's important, this one's not so important. You do that at packet level. And then finally, and I'm doing a real simple, quick blow-through of this, then you can do policing as far as packets come in. Packets come in. Sorry, I should have sped this up. There we go. And a high-priority packet comes in, it can actually reprioritize the queues. So things of high priority can go out. Now, the real thing I want to point out about this is, what is the difference between the last 3 slides and the 3 before it? What level am I controlling this at? The packet. Everything I showed you in these 3 slides has the same thing on it. If I go back in here, what am I looking at? Links. Looking at connectivity links. So true quality of service gives you the ability to have granular control of packets. Much, much different. Very important to realize. So if you look at quality of service, there's something called the trust boundary. So I've got this big network, and downstream my switches have all these policies. They examine, they classify traffic, and they police that traffic. But they got to assume that the switch downstream, I got to assume that John over here gave me the tagging correctly. So I have to be able to trust him downstream. So in a network, the layer of trust with regular ESX hosts is right here. It's the first switch you can tag at, because you can't do that up here. So there's a gap between. You get them to the 1000V and put that in, you can now tag directly inside the ESX host layer, and you bring the trust boundary all the way up to where it belongs. It's another very important thing to realize about quality of service. If you look at reporting and analysis, you've got several really cool features. NetFlow is a big one. You can actually send note flows up from the 1000V and examine flow traffic, something you can't do as easily without spanning ports. On the previous switches, you also have span and earthspan that you can actually remote monitor traffic. And with 1000V, if I got a VM on one host and I'm mirroring a port into a sensor, and I vMotion that host to another host, what happens? It works. That's important. So, the security discussion came up. If I've got a security admin who's worried that virtualization isn't going to support remote spanning for an IDS sensor or something of that nature, 1000V will support that. And you also have CDP, the ability for the downstream switches in the Nexus 1000V to communicate, as well as the ESX host. So let's talk about the future. So I kind of hinted at the fabric changes. I hinted at the changes in multi-hop for FCOE. There's another thing coming out called Trill NA02.1AQ. So the importance, I've highlighted there's an importance of layer 2. ESX hosts talk layer 2. For right now, it's going to stay that way. So because of how powerful this technology is, because of how efficient and dense it's become, that has pushed networking to reevaluate layer 2. And let me illustrate that. Mr. Whitman, can I borrow you? Rob, will you come here? So, Rob, if you stand over here. Brian, you're good right there. These are some awesome guys, by the way. I just want to say that. So let's say I'm an ESX host. I'm at layer 2. And I got myself a a packet, nice watery packet. And I look at Rob here, I look at Brian, they're both links I have going up. Well, let me rephrase that. I'm the switch in front of the SXOs, but I have links that go up. Well, if I give Rob this water bottle, and he takes it into the network, and he's still an active path, so and it comes back in through here, what happens? All you network guys, what is that called? That's a broadcast home. That's a loop. Is that a problem? That's a problem, because I'm going to do what when I get this, if I'm a switch? Here you go again. What happens? Here you go again. And until things go bad. So there's a protocol that was put in place to prevent that. Spanning tree protocol. Yeah, you guys all know that. So what do? There's a flood that comes down about packets that tells me what's going on upstream. And I go, oh, you both go to the same place. So Brian, I like you, but I like this guy better. So you'll be my backup. If he doesn't take me to dinner tonight, I'll call you. Sorry, my wife. So I go, here you go, Mr. Rob. And he takes my packet, and I just hand it to him. And if Rob, I'll take my packet back, thanks. And if Rob goes down, I can just hand it over to this guy. So how many uplinks are connected to me? Two? Everybody agree? Two? How many can I use? One. So how efficient am I? I mean, how much utilization of my bandwidth am I getting? 50%. Who out there thinks 50% of what you have available is a great number? Somebody that sells switches. No. Or cabling guys. Cabling guys love that too.
50 is good because if he dies, then you're going to be in trouble if you're using 100.
Right, well in this case, just have redundancy, I only get 50 out of it. But, so the layer 2 changes coming with Trill and 802.1aq is there's going to be intelligence in pathing at layer 2 also. So I'll be able to know I've got 2 links here and be able to send some packets this way, and some packets this way, and some packets this way, and some packets this way. Very similar to layer 3. And that there'll be intelligence in that layer to distribute across all the paths available. That is coming because layer 2 is becoming so important. Once again, if you guys can read Brad Hedlund's blog, he does an amazing job of illustrating that, especially in video. He does a great job. It's very, very important for utilization because as layer 2 becomes more and more and more important, it's even more important to properly utilize my vSpecialists. Thanks, guys. Any questions on that? No? Okay. So the other thing that's very important is right now we have how many vendors for our high-end switch on the ESX? 1. Right? So more vendors is something that's also got to happen. To validate a market, you need more vendors participating in the market because they see revenue in the market. So as more players come into it, it's going to improve things because what's great for technology to advance? Competition, absolutely. I mean, I'm an EMC guy, and I like going after NetApp, but I like that they're there because it keeps us good too. 3PAR, once that all settles out maybe, but for right now, not that great. So the other thing that's going to happen is layer 3 changes. So we've got, who here uses IP storage rather than FC? It's a pretty decent amount. It's great stuff. So layer 3 adaptations for unified storage pieces is something that's coming also. We've always thought about like network connectivity from a storage unit to at the Ethernet layer to a server as being layer 2. Why can't it be layer 3? Why can't it be multi-path? Why can't it be more dynamic? You're going to see changes there also. And finally, I wanted to pimp myself out. If you, like I said, I write a blog, nicopedia.com. I write a lot of free tools. I am on Twitter. It's the best way to get hold of me and chat with me. I will ask that if you wouldn't mind, this is my first VMware presentation thing ever, well, besides Tuesday. Please give me comments and feedback. If you got a comment on something I said or need follow-up or any information at all, hit me on Twitter or through email. Thank you very much.